Hello and welcome. Please, you can take the phone. Somebody should take the phone. Right. Hello and welcome. Today we're going to be continuing our session in machine learning. Today we're going to be looking at support vector machine. What is support vector machine? Support vector machine is a very interesting algorithm that you can use to do classification and regression. I've been doing regression all this while using the linear regression model from SQLN. Today we're going to be using support vector machine to try out some classification problem using a famous data known as the iris data set. To get going, I'm going to quickly share my screen. Who is playing that music? Divine. So I'm going to quickly share my screen so that we can take a look at this. Okay. So this is our website where we are picking our lectures from. I'm going to quickly click on the blog. Let's get to today's class. The website is Tclassified.com. So once I click on blog, I'm going to scroll down. You have different courses that we are treating: React, Node, Django. This is what we treated this morning. Machine learning, this is where we are. So I'm clicking on machine learning so that it's going to take me to where I should be. Okay, so this is where I should be. All this, we've done all this since the start of our class. So please, you can get to our website, Tclassified.com, check out what we've done so far. We said, so these are the things we studied. We use this for regression. We have assignments attached if you want to try out the assignments. But today, which is a wonderful day, we're going to be looking at support vector machine. This is what we're looking at. So what is this support vector machine? Support vector machine, also known as support vector network, a supervised learning model. So it's a very wonderful model that you can, with associated learning algorithm that analyze data used for classification and regression. Those are where you can use it, classification and regression. You can see this. This is from Wikipedia. Once you search for support vector machine on Google, you can see this reference. So this very support vector machine model was developed by Etienne and Bell Laboratories by Vapnik with his colleagues. So it presents the most robust prediction method. Until the advent of deep learning, support vector machine used to be the most famous model for machine learning analysis. And today we're going to be practicing using this for support vector machine. Now, what problem are we going to be looking at? We're going to be looking at the iris data set. We're going to be importing it. So these are the first thing we did. We imported what? Pandas as PD. Then from SQLN.dataset, we imported iris data set. The data that we've been using so far is either that is in Excel, isn't it? We save as CSV and import using what? Pandas read CSV, isn't it? But this one, this data is so popular that it came with this SQLN model library or SQL Python model. That's why you can get it in by simply saying from SQLN.dataset import load underscore iris. That's the data site. So with that, you can now, with this very function, you can load in your iris data set. So let's practice this immediately. How do we do that? You click on your search and type in what? Jupyter Notebook. Click on your Jupyter Notebook, it will be opened. So once you click on search like this, type in what? Jupyter Notebook, which you already installed. I already told us how to install this. So click on this Jupyter Notebook. Once you click on it, it's going to open up. It will open up to this. So once you have this opened up, what do? You go to this new, isn't it? The arrow beside the new, click and click on Python 3. That's the kernel we are using to run our to interpret our machine learning codes. So do that and open up your Jupyter notebook and let's start coding this out. So this one is gonna take, it's gonna be a little bit more difficult than the ones we did yesterday and the day before yesterday, but just keep paying attention. If you don't grab it at once, you're gonna grab it later. So that's one thing with coding. At the first teaching, it might look very distant to you, but with time, it becomes easier. Okay. So I'm gonna import pandas and load iris. We need these two, very important. So what do I do first? Once I open my Jupyter notebook, first thing will be to give it a title, isn't it? So what title am I giving this one? Let me say support vector machine in iris. Okay, let me just leave it at iris data set. So I click on rename. Once I do that, you see that the name of my Jupyter notebook is now support vector machine iris. So next thing will be to import pandas as PD and to import load iris from sklearn.datasets. So those are the two things I'm going to import. So I'm going to click on run. So once you click on run, the interpreter is going to do this too for you. So what's the next thing to do? You get back to our website. Next thing will be to load these iris dataset. Like I said, the iris dataset, it came in with the sklearn. Makes it easy for you to use it so that you don't need to read CSV. Okay, so loaded. So you just take the steps one after the other as it is here. Then you'll be cool with what you've done. So let me take the next step. So I hope we are getting the steps. We imported what? Pandas as what? PD. Who can tell me why we needed pandas? For our data frame, isn't it? To manipulate our data, that's why we need pandas. Who can tell me why we got in sklearn.datasets? Why do we need sklearn? Okay, from the load iris, when we say iris.features underscore name, you're simply asking it, what are the features? What are the column headers? You understand? You know, in the other one, we had what? Area. After area, we have what? Prices, bedroom, and all those things. You understand? So for this very one, what you are going to have in as the first column is what? Sepal length. The second one is what? Sepal weight. The third one is petal length, and the fourth one is what? Petal width. Those are the features that you're going to use to predict, to know whether this very flower is iris setosa or the other. There are three classes of them, but these are what we'll be checking. Just like in the first one, we needed to check the area of the house, the number of bedrooms of the house, and the what, and the age of the house in order to determine the what? In order to determine the what? Price. To determine the price, we checked what? The area, number of rooms, and what? The year, isn't it? The age. This one, in order to determine whether this is iris setosa or any class, you understand? We need to check the what? The sepal length. So what scientists did was that they went into the farm or they went into the flowering place, you understand? Where they have their, I don't know what they call it, floriculture or anything, you understand? When they see this iris plant, they will use ruler and measure the length of the petal and the sepal width. Is that clear? They took all this data with their plan sheet. Is that clear? Then they came to their computer, recorded them into where? Excel, isn't it? Or any data, any spreadsheet they are using. Then saved it as CSV, then modified it and uploaded it to this sklearn.datasets. And that's why you can reference it from there. Do we understand what features name means? Feature simply means those attributes you're looking at in order to classify. Are we understanding? So those are the attributes, and they are all in CM. They are all in what? They are all in what? So we'll go back now. So let's check out the target name. Now, when you talk about target name, what does target name mean, class? Target name simply means, now that you've looked at the sepal width, the sepal length, the sepal width, the petal length, and the petal width, if you look at them, what are you classifying them into? There are 3 classes. So we want to look at those 3 classes that you can classify them to, depending on the values of their sepal length and width. You can now classify as what? Whether it's iris setosa, or whether it's iris versicolor, or whether it's iris virginica. Is that clear? Computer is able to now look at, once you now feed a computer with any measurements for sepal width, petal length, and petal width of any given flower, computer should be able to tell you that, guy, this is iris setosa. You understand? Please, this is iris versicolor. This is iris virginica. So using the features, you're able to determine the target. Are we understanding what we are doing? So we've done that. Let's get back. So the next thing now will be to do what? I've done that. To arrange them in the data frame, pandas data frame. Let's do that. You can see the codes are very clean. But you guys, did you guys notice one thing? The codes now, the way I present it on my website now, you don't need to modify anything. Is that clear? So you see that I'm improving. Joshua, am I improving? Am I trying? I don't want to give Ibrahim too much headache working on my codes now. That's why I try to clean it up now. So Kashmir, I will give you people the secret. Once you want to put in the code in the backend, you understand? Click on code. You understand? Once you click on code, it will press exactly the way it should be there, so that we don't need to go and be arranging our single quotes and double quotes. Did we understand what just happened now? Please be paying attention. This one is actually easier. It looks like it's more difficult, but it's actually easier because the Python statements, they are very simple. df is a variable. df is a what? You are just assigning this value to this variable. So how do you come about this value? You're using pandas, which is a model, isn't it? Why? How do you know that you're using pandas? Because you say PD, and we know that we imported pandas as what? PD. So we're using pandas. What are we using in the pandas? Is data frame. Data frame simply means something that can arrange something in table. Can you see that table down there? It can fetch this data the way it is, whether it's in JSON format or in any format, arrange it in tabular form. Or if you read it as CSV, you understand? Convert it to this tabular form and present it to you on the Jupyter Notebook. That's what pandas can do. So it's using this function of pandas to do what? To look at this iris.data, which is the data. To look at the what? Iris.data, which is the data that they've collected, transformed, and you imported. Is that clear? After getting this data, you simply arrange it in columns. You simply do what? Arrange it in columns. So what column is he looking at to arrange it? He's looking at iris.features_name. And we already know that iris.features_name is the what? Sepal length, petals, and all those things. And that's why he's able to arrange it according to this. Class, is that clear? Class, is that clear? So after arranging it in this table, when you say df.head, class, df.head, what is the meaning of df.head? df.head simply means show all the first 5 rows. Show us the first what? Show us the first what? That's what .head means. If you say only df, what will happen? Who can tell me what will happen? We've been saying df since, and we'll be seeing what will happen when you say df. Huh? Let somebody tell me what will happen if you say only df now. You people should stop dulling me. We've been saying df in the previous ones. It's this one that we started df.head. It will show everything. Thank you, Kashmir. You people should be thinking. So let me try it. Let me remove all this .head and rerun. Can't you see it's showing everything now? It's showing everything. You see that the data is up to how many? 150 rows. It's even taking out some in order for you to enter. Can you see this dot? This dot simply means that there are plenty things there. So let me get back to .head. I told you guys that this thing is very simple, but it's just that you have to take it easy. You have to do what? Take it easy. Who can tell me why is okay? Is it okay?
No, you didn't.
I'm supposed to put this, but okay. Are we clear on this? Can I continue? It's perfectly cool and simple. Okay, so let's continue. So once you say df.head, you see in this one I showed you both the code and the answer is given, isn't it? Makes it easier for you so that you can be seeing when you're making mistake, you can see your mistake. So I'm going to pick out. So if you're picking this out by yourself, which one are you picking out? Is it the in or the out? Class, is it the in or the out? The in, isn't it? When you click on the run, the out comes out. You see, that's why you guys are preparing for this competition, because I know that by next week, Kasmer should be able to write these codes from his head. Abi? Kasmer, you're going to be writing this thing from your head by next week, Abi? But I trust you. I'm not doubting it. I trust you to write it from your head. After all these ones we are doing, we are going to be start coding this thing physically, not pasting. Don't be pasting too much, except when you've understood it very well. That's when you paste. So very soon you start typing it out. So we are going to do df target. Df simply means data frame. Like I said, data frame equal to what? Iris.target. So let's get the targets. Here we got the features. Is it not the features that we got here? The features determine the target, isn't it? You use features to predict the target. That's the essence. So let's get out what our targets are. So now we're having our features and we're having these targets. So these targets, I want us to notice something. Class, are we listening now? You see that we have only one target, and all the targets are 0, 0. What options do we have? We have 3 options, but it could be Satosa, it could be what? Vesicular or Virginica, isn't it? That means it can be 0, it can be 1, or it can be 2. Class, do you understand this? If this target is 1, what value will it be? What class of flower will it have been? If it's 1, it would have been what? Vesicular, isn't it? If it was 2, it would have been what? Virginica, isn't it? So to test this out, I'm going to, instead of having df.head, let me see the other ones so that I can see all of them and see what they are up to. So you can see that we have 2 here. Can you see 2? So these 2 simply means what? Virginica, isn't it? 1 is vesicular, isn't it? So you see, once you say .head, you simply want to get only the what? First 5 rows. First what? First 5 rows. So I'm going to take this out again. I'm going to have my head. When they say they just want you to see how the data looks like, but they don't want to show you everything. So I'm going to go back so you can see my first 5. So you can see that this is almost like a complete table because you're having both the features and the target. Is that clear? Both the features and the target. You can be, instead of hearing target, some people might use the word label, but some people might use the word what? Label, because you're classifying to the labels. Features are the data you're looking at to get your label. Are we together on that? You can be hearing the word label instead of target, so don't be confused. So what actually happens? Who can tell me what happened in this code? Class, are you listening? Class, are you listening? This is the normal Python code. If you want to add an extra element to your list, is that clear? You don't put what you want to be the label of the list, which is target. This target that is here. You understand? What do you want to be under the target? You want iris.target, and you already know that iris.target simply takes these this value, whether it's Satosa, vesicular, or the other ones. Okay, so let's continue. So the next thing will be to what? Are we together? Who can explain what just happened now? Who is very fast to explain what just happened? What is this command doing? Vesicular, thank you. That's what it's doing. You understand? So from the output, you can easily decode what the code is trying to do. It goes to the data frame. You know we have data frame. Data frame simply contains all our data. You understand? Then it's not trying to tell it df.target equal to 1. That it should just go to only where targets are equal to 1. And we know that once target is equal to 1, that is vesicular. If target is equal to 0, is what? Satosa. If target is equal to 2, is what? Virginica. So it's telling it, please, I want you to get me the first 5 dot head. Simply means the first 5 rows. But I want it to be only for versicolor. Are we together on that? So if I change this thing to 2 now, class, see what you're going to see. If I change it to 2 and run, we see only the target 2, 2. I told you, Casmer will be cool. Will code this thing for me by next week. It will be so simple for him. Once he has read, he will have to read it again. You see that it's very, very simple. Okay, let's get back. So all the codes are on our website, very simple way. We did it like this because we want it to be simple for all our students, okay? You can see that the next instruction is simply telling it to get the targets at what? 2. And with target at 2 is what? Who can tell me? Virginica, isn't it? So the target now is 2. And this is the first 5 rows for this one, this target, okay? So what's the next thing we do? Okay, let's do the next thing. The codes are not much for this. You're going to see it. So who can tell me what's the difference between us bringing in the data here and the ones we've done so far? I just explain it now. Who is sharp enough to re-explain it to me? The other one we used .recsv because we already had our data in our Excel, isn't it? But now we just loaded because this data is coming from sklearn data set. So it's pretty much easier. Okay, so this is what it just did now. The data frame, we already know the data frame, isn't it? The data frame is the data containing the what? The features and the target. Now we want to add another column, another field. Is that clear? I want to name that field flower underscore name. Can you see that field flower underscore name? Can you see it now? Now, what value do we want to put under it? We want it to go to data target. Is that clear? When it goes to target, that it should be checking all of them one by one. That's what this lambda, you understand? It's like a for loop. To be checking all of them one by one, you understand? Then anyone he sees, he check. If it is 0, assign it to Satosa. Ibrahim, are we understanding this? If it is 1 that is the target, assign it to what? Versicolor. If it is 2 that is the target, assign it to what? Virginica. That's what it does. And that's why we're able to have this extra column. So it checks this. Why is this Satosa here? Because all the targets that we are seeing here are what? They are what? They are what? Zeros. So if I remove this head to show all of them, you're going to see that it will show for every of them. Can you see 2s now? We're having Virginica. So let me take it back to dot head. So you can see that this one is pretty easier to understand. So let's move forward to the next code. Okay. I hope I'm trying so hard to explain this one today, each line of code. Are we trying? Ibrahim, are we doing well today? We're not running it down the way we ran the first 2. But I ran the first 2 down thinking that you people will look at it at second time and understand it. But this one, I'm picking it one by one. Okay. So who can tell me what happened? What happened is very clear now. Kasmer, tell me what happened. Oh, no. Kasmer, people at the back, they are understanding. Let me ask people in the front seat. Anselm, are you following? Can you tell me what just happened with DF, then inside block bracket, 45 by 55? What happened? Samuel, tell me what happened. Right, okay, you know, you don't, is it Excel that is also your problem? Okay. Please, who can tell me? No, can you tell me what happened? Bro, can you tell me what happened? The lot of you, can you tell me what happened? Oh, yeah, so let me ask the people that understand what happened. People at the back, Kasmer or Joshua, I think 2 of you understood what happened clearly. From 45 to 55, very simple. That's what he did. He checked the data frame. This is our data frame. This table is our data frame. Is that clear? Then he's picking out what? From 45 to what? 55, but not including 55, isn't it? From 45 to 55, but not including 55. That's how you bring it out. This, do you know what we have been doing so far? Who can tell me what we've been doing? We've not started the regression. If you did not do all these things, you will still get your regression done well, your classification done well. You understand? But now we are learning pandas. We are doing what? You are learning pandas. That's what we've been doing. Somebody will ask you, do you know how to use panda? You say, no, you've not learned pandas. Or do you know how to use matplotlib? You say, no, you've not learned matplotlib. You understand? In an actual sense, I would have taught you pandas on his own, taught you matplotlib on his own. You understand? But instead of wasting all those time, and we know we are having targets of going for our hackathon, you understand? We now use pandas, we use matplotlib. You know that what we use matplotlib is to plot graph, isn't it? We plotted with it. What do you use pandas for? To manipulate your table inside the Jupyter notebook, you understand? And arrange them. And that's what we've been doing so far. So that is what we'll be using pandas to manipulate our table. Once we get to the actual classification using the model, I will tell you that when we get to that bit. Class, is that clear? Is that clear? So Joshua, if they ask you what do they use pandas for, you understand? These are what we can use pandas to do. We've already seen what we can use matplotlib to do, isn't it? Who can tell me why we did not import matplotlib in this class? Because we are not planning to plot. Oh my goodness. Who can tell me why we did not import NumPy too? We are not planning to use that, you understand? But in the first class, we used it explicitly, and we got it as needed. Okay, so let me continue. So what's the next thing I do? Okay, so what we are doing so far is what? Using pandas. What we are doing so far is using what? Pandas to manipulate our data. Okay, so I do this run. Okay, so let me continue. Okay, so you can see what happened here. In this line 14, we imported matplotlib.plt as what? PLT, because at some point we might need to plot. And it's always good. It's always good that you import what's it called? It's always good that you import matplotlib. You understand? In fact, anytime when you go to competition and want to write out your what's it called? Your machine learning code. You understand? Always import sklearn, import pandas, import matplotlib as PLT or anything. Import all those basic things that you need. Always do that. Okay. So let me import matplotlib as PLT. Please, as we are going, I will explain the one we just put. No. It's a comment. Yeah, it's a comment. So just import only matplotlib.pyplot as PLT. That's the only one I imported. Okay. This other one, matplot inline, I did not do that. Let me just check it out. So you can see from the statement, simply say matplotlib inline. Simply means that instead of importing it here, that we would have imported it. We did it inline when we are writing the code. Are we clear on that? Okay. So I take it out, get back here, run. So that's where I am still. Okay. So can we plot this? Can we plot it out? So this is how we plot. We've already known about plotting before, have you? Have we tried plotting before? Huh? Kashmir, have you tried plotting? We've tried plotting. So let's put in this plotting code and explain it. Okay. So we have an error, but I'll check it out. But before that, let me explain this. PLT is we imported matplotlib as PLT. We already know. So on the x-axis, we are putting what? Sepal length. On the y-axis, we are putting what? Sepal width. Then we did pair till dot scatter, which is the scatter plot. So we are plotting the sepal length in cm, sepal width in cm, color green, marker plus, and another plot sepal length, sepal width, color blue. So those are what we are plotting. And this, what will happen here, are we looking at up here? What happened here is that we just created this variable, df0, df1, and df2. You understand? Then we went to the data frame and assigned the from 0 to 50 to it. Then we assign for df1, we assign 50 to 100 data. You understand? Then for the df2, we assign 100. So this is simply assigning. And these are where we use them actually. So what could have been our error? So it said out 17 line 5 invalid syntax. So why are we having this error? Let me see. Line 5. 1, 2, 3, 4. Please, if you see my error, if you're able to see it first before me, let me know. What could have been my error? Okay, let me see line 5. Df head, iris underscore names. This is okay. This is okay. This is okay. This is okay. These are just pandas. Okay. Okay, so I'm going to sign off and I'll check out my error, solve it, and get back to you. See you when I see you.